Wonderful. Let's go ahead and take a look at your Bellwork then for today. We need to be able to apply, right, our derivative shortcut rules now, regardless of what kind of function we're looking at. And so it looks like we've got a straight power rule for our first one. We know that the derivative of a constant times a function is just the constant times the derivative of the function. So we can go ahead and apply our constant multiple rule, and then we'll just simply do exponent times the base raised to 1 less. It doesn't matter that my exponent is a fraction. I can still subtract 1 from 2/5. And when I do so, 2/5 minus 1 would be 2/5 minus 5/5 would be, what, negative 3/5? Is that right? Negative 3/5? And then we'll go ahead and make this look a little bit prettier. We know that we could do the 4 times 2 is 8 on top. The 5 would go on the bottom. And we know that a power with a negative exponent, right, doesn't mean negative answer, it simply means reciprocal. And so I'd rewrite that x to the negative 3/5 as 1 over x to the positive 3/5. Go ahead and check your answer. And raise your hand if you had the same as the red, 8 over 5x to the 3/5. Good, so you can still subtract 1 from your exponent when applying the power rule, whether that's a fractional exponent or not. I'm going to go ahead and box this so it's PDFable. Striving for PDFable. Okay, then how is that different than number 2, right? So how is that problem different than number 2? Jake?
There's no variable present.
Absolutely. There's no variable present in number 2, and so f of x equals 5e to the 3/2 is a constant function, right? And what's the derivative of any constant, Michaela?
0.
0, and so number 2 should be 0. Raise your hand if you have that. 0? Awesome, and I hope that didn't bite you on the test, right? Some people differentiated 5e to the 3/2 or something similar to that, right? But they did the power rule, and remember, e is just a constant like pi, and so we had, several of those in our mental derivatives and stuff like that. All right, so don't worry, it might not have been you. I mean, it might have been you, but it might not have been you. Let's take a look at number 3. If t is given by 5 sine x cubed, now we've got a couple things going along. So ladies and gentlemen, we've got a constant multiplier. Don't worry, that'll stick around for the party. So we've got our 5 sine, and now the derivative of sine of x cubed. Here we've got a composite function. It's not just sine of x, not just sine of theta. It's sine of x cubed, itself an inner function. So we'll apply the chain rule. The derivative of sine goes to cosine with the inner function. In this case, my inner function was x cubed, and then times the derivative of the inner function. The derivative of my inner function is 3x squared. Let's go ahead and do one rewrite to make it look nice. Looks like we've got the 5 times the 3 is the 15x squared cosine of x cubed. Go ahead and raise your hand if you have the same. 15x squared cosine x cubed. Way to go, you guys. Good job. All right, then let's go ahead and contrast that with our answer to number 4. And number 4, we're not differentiating 5 sine of x cubed. Isn't that 5 sine of x cubed? Well, that's 5 sine of x cubed. And so if we're thinking about this, right, our order of operations here, if we were to rewrite this, change our overall function. No longer is our overall function a trig function where we'll differentiate sine to cosine. Our overall function is a power function now. So when I apply my words, my overall function derivative is going to be the power rule, then my inner function will be the trig rule. Let's go ahead and see what that looks like. So constant multiplier, y prime equals 5 times, and now we'll go ahead and do the power rule. Exponent times the base raised to 1 less, right? Then times the derivative of the base. That inner function wasn't just x, it was sine of x, and so now we do the times the cosine of x. So these are meant to be similar, right, on purpose to make us think about the difference between my overall function versus my inner function. It appears as though we get 15 cosine x sine squared x, and you could do any order for that. So raise your hand if you had number 4 right. So did you get number 4 right? Way to go with the derivative of the inner function. Nice job, you guys. All right, what questions do you have about the first 4? Then, true or false? If s of x is given by the sum of f of x plus g of x, then s prime of x equals the sum of the derivatives. That is f prime of x plus g prime of x. Go ahead and turn to someone close to you and decide if that's going to be a true or false. Be ready to share with the class. We don't have left-right partner pairs. We just have front backers. All right, enough talk. Now we eat. So number 5, what do you guys think, true or false? What did you come up with? Hayden and Emily?
True.
True, raise your hand if you had true. True for that? That's true, that's just our sum or difference rule. So if we are taking the derivative of a sum of individual functions, we can simply differentiate term by term, and we'll get the sum of the individual derivatives. So that's definitely true. Wouldn't that be cool if that was an infinite corner? Yeah, it would be. All right, now let's see P of x. So while S of x, careful how you say that, S of x was standing for sum, what do you think P of x stands for? Yeah, so if P of x is given by a product of functions, call them f and g, is P prime, and this was meant to be our setup for our activity. Those last questions, 4, 5, and 6 in your homework. Is P prime of x given by f prime of x times g prime of x? Jake?
No.
No way, Jose. So that's not equivalent. So that's super false, right? Super false. Superstar. Super false. All right, and lastly, if Q of x, Q for fraction. Wait, no, that doesn't work. Quotient, yes, quotient. If Q is given by f over g, then true or false, Q prime of x equals f prime of x over Q prime of x. So what do you think about that one? Nikki? False as well, and so I am going to grab 3 of those at least 3 of those. So that's true false too. And so several people, right? Several people on that ln of x1 that you guys differentiated. After your first rule, you differentiate the top and differentiate the bottom separate, or if you didn't simplify, you differentiate the first term and then times the derivative of the second term, right? And that was an incorrect application of a product. And so what we're going to do today is develop the correct product rule and the correct quotient rule during our activity. You're going to earn stamps at up to 5 different places today. So we've got a big one, right? We've got a big activity today. And then we're going to come back together to get our derivative of the product in words and then apply it for practice, and our derivative of our quotient in words and then apply it in practice, okay? And so we're going to do each of those things. But first, we've got to do a couple of homework checks. There's a stapler on the front table and the side table. Please make sure that your review OTL has your correct heading on it, name, first and last, 2A, number 10, that's your review OTL. Give yourself credit for those you completed, please, out of 29. Divide and multiply by 2, and then we'll box your answers for a nice thing on top. This does not include your alphabet challenge or your prerequisite skill review. This is just a review, please. Just a review at this time.
Okay.
Only review, please. Once your stapled Infinite Campus scored up, please pass from the back to the front. I know we're a little out of order. It's okay. Pásamelos, por favor. Thank you for your help, ladies and gentlemen. I appreciate that. So today, we're going to develop the correct rule when we differentiate a product of 2 functions or a quotient of 2 functions. By the end of today's activity, we'll have developed rules to handle these, and we'll state those both symbolically and in words so that we can practice applying those rules correctly by the end of today's class period. Stamped eligible items include 3B, 5B, 6B, 11B, and 12B, okay? We should have already changed, I think when I made the copy work, excuse me, I already fixed this with my super duper big eraser, so everybody take a look at 6A. 6A should not include an X squared in front. Good. So this should be gone, and it is, and so we don't need that. Awesome. So you're good to go. Okay, ladies and gentlemen, I know the desks are in testing formation, so what I've tried to do is put them on this line. If you guys can look down, the front of your desk should be on the line. Yes, at the end of class, let's put them back in the same place along that same line so that my algebra class next hour can take their test. But for now, let's go ahead and scoot into our groups. And for today, you can form your groups of 3 or 4 by scooting desks into little islands, okay? Thank you, and I'll pause the recording. We'll come back together for our words. Okay, so we want to make sure that we're comfortable finding the derivative of a product of 2 functions or a quotient of 2 functions. And so we want to have our rule for the product rule. We want to have that symbolically, right, with prime notation, and we want to have it verbally with written words. And so let's go ahead and take a look. Suppose that y is given by a product of 2 functions, u times v. Go ahead and tell the class with primes, right, with primes, what would that look like symbolically as an equation? Y prime equals. Be ready to share. So what do we have for that? Hayden?
U prime times v plus u times v prime.
U prime times v plus u times
v prime.
Absolutely. Thank you, Hayden. Raise your hand if you have the same product rule. Good. So we ran into that a couple of times. We were given it. What we want to do is make sure that we have the appropriate words for that. And so on the next slide, I went ahead and wrote down our words. Would I let u be the first function, and if I let v be the second function, then the derivative of a product of 2 functions is the derivative of the first function times the second function plus the first function times the derivative of the second function. And so now we have it symbolically and verbally. Take a minute and make sure you have an equivalent verbal statement. So the derivative of a product of 2 functions is the derivative of the first function times the second function plus the first function times the derivative of the second function. In just a minute, I'm going to call on someone to share with us the derivative of a quotient of 2 functions using the prime notation for symbolic. So once again, we'll do the equation first with primes, and then we're going to state it in words. So be ready. Okay, if we're given a function u that's a quotient of 2 functions, call them u over v, then y prime is given by what? With prime notation. Savannah?
The derivative of, uv, u prime times v minus v prime times u over 2 v squared.
Awesome. So we've got u prime times v minus u times v prime all over v squared. That is the denominator function squared. Let's go ahead and make sure that we have an equivalent verbal statement. The derivative of a quotient of 2 functions is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Notice how being specific with numerator and denominator, we don't have to worry about which is the first function, which is the second function. We all know what the numerator of the fraction is, the denominator of the fraction is. So the derivative of a quotient of 2 functions is the derivative of the numerator times the denominator minus the numerator function times the derivative of the denominator, and then all over the original denominator squared. Now, back on your note sheet, let's go ahead and complete our closure for the day 1. For product and quotient rules, everybody back on your note sheet, please. And you can complete with prime notation on your regular note sheet for day 1. If P is F times G, then P prime equals. If Q equals M over N, then Q prime equals. And last, but certainly not least, if y is pi to the 3/2, then y prime equals. Be ready to share, and I'll call on you in just a minute. Okay, if P is given by F times G, right, then P prime is, Marissa?
F prime times G plus F times G prime.
Raise your hand if you have the same thing for number 1, product rule. Good job, you guys. If Q is given by M over N, then Q prime equals, with prime notation, Nikki?
M prime times N minus M prime times all over.
Awesome. Raise your hand if you had the same as Nikki. Good job. And lastly, if Y is pi to the 3/2, then Y prime equals, Kobe?
0.
0. True that, my brother. And so the derivative of any constant function is 0. Way to go. Great work today, you guys. I'm going to go ahead and turn off the recording and save that. You guys